wanna learn, put your mind to.
I want you to run as quickly as you would if you thought a dog was about to chase you. That's how quickly I want you to run towards your dreams. Okay, boom, we want to get started today. What are we doing today? Today we are doing Euclidian Geometry, right? That's what we'll be doing today. So, what do we need to remember about Euclidean Geometry? There are things like triangle rules, like your isosceles triangle, your other different triangles, the ones that have all sides that are equal, the one that has no sides that are equal. You need to remember all of those rules, but especially your isosceles triangle rules, because you'll be using that a whole lot. You need to also look through your straight line rules, like your F, like how in that F you have those lines that are corresponding, right? This angle and that angle will be corresponding, or that the straight line equates to 180, or your U. You need to remember that. So that the angles on the inside are co-interior, or the angles that the two lines that cross each other, those two angles are vertically opposite. You need to remember all that and go look through all those rules, because you will need to use them in Euclidean geometry, right? And also, very important, you need to go look through your circle geometry. Look at your proofs, look at all of your circle geometry. Remember, revise all of that, like how the angle at center is equal to 2 times the angle at that circumference, right? So you need to go look through all those rules. I will not write all those rules. You did that in grade 11, and it's tedious amount of work that that is not really necessary, because you just need to look through it once and it will come back to you, right? So today, what are we doing? We are doing ratios and proportions. Ratios and proportions. It starts with theorem 1. What does theorem 1 say? It says that EB, the line EB, it says that the line drawn parallel to one side of a triangle cuts the other two sides in proportion. What do I mean by that? So if, say, for example, my triangle ACD, right? And then we draw a line right there, EB, which is not in the center. It doesn't have to be in the center, because it cuts the lines, the two sides, AC and AD, in proportion, right? So what does that mean? So since EB is parallel to DC at the bottom, AB, right, this from here to there, divided by BC is equal to AE over ED. What does that mean? What I just said, what does it mean? It means that it's in proportion, right? So the proportion of AB and BC, so the proportion of AB divided by BC is equal to the proportion of AE and ED. And if you look at that carefully, I can't say AB divided by BC is equal to AD divided by AE. Those are not the same. I have to match the same side with the one on the other side that is exactly the same as that one. So that's why I go AB divided by BC, and then I start with AE, which is the longer one on the other side, divided by ED, which is the shorter one on the other side, as I did in that form over there, right? So there's also different variations of this, right? The different variations can go from AD, right? AD, I chose the longest one, divided by AE, the shorter top one, right? And then on the other side, which one would I start with? I would go from A to B. No, I go from A to E, and then I do the shorter one, A, B. Because the last time on the other side, I started with the long one, then I went to the short one. So on the other side, I also have to go the long one and then the short one, because this is a ratio, right? And the ratio is saying that those two ratios are equal. So basically, that's what theorem 1 says. It says that when you draw a line that is parallel to one of the bases of the triangle, right? To any side of the triangle, really, it cuts the other two sides in half. Not in half, in proportion, right? So that's what basically that theorem 1 says. But there's also the converse of theorem 1. The converse of theorem 1 is just looking at this backwards. So what does looking at it backwards say? It says that if the results, we already know the result. We know that AB divided by BC is equal to AE over ED, meaning that these two sides are in proportion, right? It means if we are told that those two sides are in proportion, Therefore, we can conclude that EB is parallel to DC. Let's say they didn't give us that these two lines are parallel, right? They didn't say those two lines are parallel. But then they say AB, right, divided by BC is equal. Use social media. Don't let social media use you. Right? It's as simple as that. If you want to promote something, use social media. Stop letting social media distract you from focusing on your schoolwork, on your life goals, on anything really. Equal to AE divided by ED. What does that mean? It means that those two lines, that one and that one, are parallel. That's how we can prove that those two lines are parallel using the converse theorem 1. Right? So now let's do an example. Let's do example 1, right? Let's see what example 1 says. Example 1 is a triangle, right? And they gave us that BD is parallel to CE, right? So, since we've already seen that there's a line that's parallel, we know that we have to use theorem 1 and not the converse, but the regular theorem 1 because they already told us those two lines are parallel, right? And they gave us AB dot dot BC is equal to 3 dot dot B. Those dots or semicolons mean that a proportion. It means that AB is in proportion with BC. So AB is in proportion with BC. And then they gave us AE. They gave us AE 12 centimeters, right? 3, 4, those are proportions. Those are not actual values of what the lines are. Those are proportions. So that's why AE is a centimeter value. So it is an actual value. It is not a proportion. And so that's why when we say calculate AD, we want an actual value, not a proportion. So we want an actual AD value that is in centimeters. We want to know how long is that line. How long is that line in centimeters? Because we don't know exactly how long AB is. But we know the proportion that it is in. It's 3:4, right? So, by the way, my graph might not be looking perfectly the same as it's supposed to as the numbers, but it's just the idea, right? So let's start doing the example. Where do we start? Okay, let's start with what we already know. What do we already know? We know that AB divided by BC is equal to 3/4. What does that mean? It's telling us that AB divided by BC is equal to 3/4. This is how I can rewrite what the dots that they gave me in a format that I am used to. So AB over BC. So if I write AB on top, I have to put the value of AB on top, on the other side. So that is that, right? Now let's move on to the next part. What is the next part? The next part is, let's look at the formulas that we know. So AB, right, divided by BC is equal to what we know already. AB divided by BC is equal to, on the other line, what is it equal to? It's equal to AD divided by DE, right? This is what we already know. We know this, right? This is what we know. So, since this is what we know, right, can we use it to find out what the value of AD is? What values do we have in this formula? We have AB. Do we have AB? Yes, we do have AB. Do we have BC? Yes, we have BC. Do we have AD? No. That's what we're looking for. Do we have DE? No. Can we calculate it? No. So we can't use that formula. But it's a good place to start. So let's look at the other variations of this formula. We can write it as AC divided by AB is equal to AE divided by AD, right? So AC is the long side, right? So on the other side, on top, I have to have the long side, which is AE. At the bottom, I have the short side, AB. On the other side, I also have to have the short side, which is AD. Let's look at our values. Do I know what AC is? No. But can I calculate it? Yes, I can, because I can add all of the ones on this side. I can add AB and BC to find what AC is. Why can I add those? Because those sides are in proportion. Those sides are proportions. So on this side, I only want to deal with proportions because that's what I only have. So to find AC, I add AB and BC. What does that result? That results in me getting 3 plus 4 divided by what? Do I know what AB is? AB is given. I already know it's 3, right? AE, right? Do I know what AE is? Yes, they gave me what AE is. But AE is a centimeter, right? It's an actual unit. So that means that AD has to be an actual unit. Whoa. Units. So AD is what I'm looking for, so I don't know what that is, right? So now I only have one variable that's missing in my equation, right? So what do? I solve for AD. How do I do that? Let me add first. So this will be 7 over 3 is equal to 12 over AD. Right? There are different ways you can solve for this. But I would just multiply. I would multiply both sides by 3 and then multiply both sides by AD. So that will result in me having 7 AD is equal to 12 times 3. Right? So therefore the answer of AD would then be equal to 12 times 3 divided by 7, which gives me what? 36 divided by 7. So it gives me 36 divided by 7, which is what? Which is equal to 5.14 centimeters. Why? Because this is an actual unit. What did I say? I said on this side, on the left side, I only have proportions or ratios. Those are not actual units. Those are proportions because they gave it to me as 3:4. 3:4 could be the simplified value of the actual values. So on the other side though, they gave me AE, which was 12 centimeters, which is a unit. So that's why on that side, when I get AD, it would be a centimeter. It would be a unit. So that is my final answer. Pretty straightforward if you ask me. That's 3 marks. So yeah. So also, let's look at, while we're on Euclidean geometry, midpoint theorem. You need to go revise your midpoint theorem because that question could be asked. They could ask you to prove that. So go and look at it, be comfortable with it, know how to prove it. I will not do it. Yeah, there's no need for me to do proofs. Yeah, okay? Okay, now let's look at similarity. What does similarity say? Similarity gives us theorem 2, right? Theorem 2 says that equiangular triangles are similar. What does equiangular mean? It means that triangles that have the same angles, right? So, like this for example, if we look at our triangle, saying that P and A are the same, are equal. Q and D and E are the same, right? And R and B and C, those angles are equal. That makes them equiangular. So since they are equiangular, we're saying that they are similar. That's what theorem 2 says. So we're saying since triangle ADC, which is ADC, is similar to triangle PQR, right? Similar, this is how you show similarity. Therefore, we can conclude that AD, this long line, over PQ, which relates to that line on that side, right? So it has to match up, this line on this side has to match up with the line on this side. Since those two triangles are similar. So you're saying AD divided by PQ is equal to AC divided by PR. So AC divided by PR. So we are saying again, those two sides are in proportion. These are proportions, right? These are proportions, not actual values, but proportions. They could be actual values, but this is saying that is in proportion. So AC divided by PR, which is also equal to DC over QR. So the base on this side has to match the base on that side. So why can we conclude that? Because those two triangles are similar. Why are they similar? Because they are equiangular triangles. All the angles are they're not exactly the same, but they are the same to each other. They correspond with each other. So Q and D are the same, for example, and P and A are the same, right? So That is basically it on theorem 2. So now let's look at theorem of Pythagoras. Theorem of Pythagoras, right? This, what does it say? It says that these three triangles, I hope you can see the three triangles here. There's one on the outside, the big one, then there's that small one on the top and the small one at the bottom. Theorem of Pythagoras says that if all of these triangles are similar, there's a proof about it. You can go check it out in your textbook. It proves that all of these triangles are similar to each other. So since all of those triangles are similar to each other, we can conclude that AB, right, AB in the big triangle divided by CD in the smaller, in that small. Stop caring about what everybody else thinks and just do you. Triangle. So we're dealing with the big triangle and the small triangle at the bottom. We can then say AB, that line there corresponds with the line CD in the small triangle. Why? Because all of these two triangles are similar to each other. Is also equal to AC in the big triangle. So the long line in the big triangle is similar with the long line on the small triangle, which is BC. So AB divided by CD is equal to AC over BC, because that is the proportion, and that can happen because they're similar, right? So that's how we end up with that. And there's also a different variation of this. There are lots of different variations. Let me show you one more. CD divided by BD. So CD in the small triangle and BD right there in the other small triangle. So we are dealing with these two small triangles in the moment, right? Those are the two triangles that we are dealing with. So we say CD, what line matches up with CD in the other triangle? It is BD, right? Because those two triangles are similar, so those sides would be in proportion. So CD divided by BD is equal to BD again in this small triangle, the one at the bottom, divided by AD, the AD in the small triangle at the top. So what do you notice here? You have BD and BD on both sides. Why? Because these two triangles share a line, right? One of them was relating to the triangle at the bottom and the other one was relating to the triangle at the top. So that's how we end up with BD squared is equal to AD times CD. Why? Because I multiply AD on both sides and then I multiply BD on both sides. That's how I end up with BD squared is equal to AD times CD. Right? So this is one of the variations that you will definitely get in your exam papers. So know how to do it. Know how to solve it. Be comfortable with it. Look at your other variations. Try to find other variations of these type of things in this triangle on your own. And look at the proof. Okay, get comfortable with this stuff. This stuff is easy. Right? Get your free marks in paper 2. Boom. Okay? Go check out the next video.